All right, we are now live.
Okay.
Or recording, everyone.
Sorry about that, me.
That is okay.
It happens.
I don't know what's going on here. So anyways.
Use the following information for the next two questions. And then the question we're being asked is, what is the value of the test statistic?
So
let's see.
I did that earlier. I'm not sure. Is the value is the t, right?
I think so, yeah.
So I did that earlier and I got 2.
Let's see. So, okay. Let me open Excel.
Don't touch it. Hold on, sorry. Hey guys, don't touch it. I'm not gonna be happy. Yeah. Can they just send somebody to come out again? Please.
Okay, so we are looking at t equals 2.2 minus 0 over.
The formula we're using on that is the t minus equals d minus mu d divided by SD over the square root of n.
Right.
Yes.
Again, I watched the video.
So I got 2.
So it's 2. So in the end, we've got 2.2 over 1.1, right? No, 1.1. Wait, 2.2.
1.1.
Isn't that over 1. Oh yeah, 1.1. Okay, so yeah, it's 2. So t equals 2. Okay.
Okay, the probability of obtaining test statistic greater than Jordan's test statistic is that 0.0403 p-value of the hypothesis test. And this is the one that he
is it the probability applet we go?
Well, this is the one he gave us the video on, right? And he talked to us about this one when you use the p-value is always both tails. And then he said, you know, the greater was a keyword.
Between.
Did you guys watch that?
Mm-hmm. The between is in between the 2 lines.
T is 1.1. 1. And then, so we use the student one, right? The student applet.
Not the t distribution, right?
Yeah, we need to do the. Well, I use the student probability applet. Yes.
Yeah, and then the degrees of freedom would be 8, right? Because that's 9 minus 1.
Right.
And then
1 minus.
You have 9 minus 1, and then.
And then, so you said we have to have both tails shaded?
That's what he said, because a p-value is both.
Oh, it's also the pass rate.
But how do we? Then how do we? So
how he was saying it is that you have to like multiply the 0.0403 by 2. So it'd be 0.0806. But I didn't know if that was the answer, or if that's what we had to plug into the probability thing.
Okay. Oh, great. We will
so that is 0.0806.
That's what I didn't get. If we're, you know, if that.
But the T
Hold on,
is
let me see.
the T is the 2, isn't it, that we got?
Yeah, the T is the 2. And where did you get the degree of freedom? Hold on, how did you calculate that one?
The number of, I don't even know what we're talking about right now. The number of,
N minus 1, yeah.
yeah.
N
the
minus
sample
1.
size is 9. So it's N minus
Okay.
1. 9 minus 1.
Okay.
So yeah, well the 2, see they already gave us, that's giving us the 0.0403, but he's saying we need to do both because a p-value is always both tails because it's a 2-tailed.
Or both sides in the middle. Or
Not in the middle.
Hold on.
The middle's 1. That'd be 1. We don't want everything.
okay.
So I think it's just 0.0805.
Point
What was the question? The
0.04,
probability of this is greater than,
I guess 0.081. 0.081.
oh, okay, that makes more sense. 0.081.
Because see, that's what the 2 tails p-value is.
Yeah,
Mm-hmm.
okay, that makes sense. Okay.
Using the data from Chapter 12 Data Excel to answer the next 6 questions.
A.
So let's see, paired sample.
So
test.
this one, we use the, which one is that one?
Paired sample.
No. The paired sample, yes.
I opened
And
that,
you-
where to go? Yes.
And you have to be really careful on which one we put in first.
So you guys see mine open right now.
Yeah.
Uh-huh.
So what's our question first? What is the test statistic? What's
Point.
that variable again?
The T.
The T,
The
right?
T.
So that's it right there,
Yeah.
right? 0.407. Oops, 0.407. That makes it a lot easier, huh?
Yeah.
The p-value is, let's go back down to 3.0689.
0.689, yeah.
What is the correct decision based on this evidence? So that's above 0.5, so then we would fail, right?
Well, it's actually 0.1, but it's still above, so it
Fail
would
to
fail, yeah. Yeah, I think so. Isn't that what it is?
Let me see.
How is this not?
Oh, okay. Let me check the thing.
How do they not have that on this thing? It should be as simple as if this is above a certain, you could put it in, and if it's above that, Excel should tell us.
Oh, that's why that they make us think.
No, thinking is way overrated.
I'm with
So,
you. But I think that's right. I think when it's bigger than the alpha, then you fail to reject.
Right. That's what I remember.
Okay.
I could be wrong.
No, I think that's what I just.
No, because it's higher. If it's a negative, then you reject the null hypothesis. But
Yeah. Suppose your alternative hypothesis is instead that the mu is greater than 0. Let's look at what this is. I guess we should look at the actual hypothesis, right?
Equal to 0, or no,
Well,
not
Not equal to 0. And it's
pretty much the same.
0.1, but that's where we said, okay, it's 0.7, or it's 0.7 almost. So that's where we failed to reject. So now it's saying, suppose your alternative hypothesis was instead that the
Wait a second.
thing is greater than 0. What is the correct decision based on that evidence?
Hold up. Can you open the Excel page again? So where is it?
It's great. Is it less than or greater than? Hold on. Did it
Is that a little better to read?
Oh, here we go. Okay, so we just need to change the type of test to
greater or less than that one?
This one?
Right below the, yeah.
So, right, is it greater than? So, P 0.3.
So it still failed to reject, right?
There's your null hypothesis, confidence level 95%.
So we have insufficient evidence that the mean of the differences is greater than 0, or let's see.
I think it'd be greater. We have insufficient evidence that the mean is greater than 0.
We have sufficient evidence, right?
Insufficient, right?
Insufficient.
Because it's still greater
really change
than the 0.1.
Mm-hmm.
So that's number. I'm on the right one now, right?
Yeah. Well, as far as I am guessing.
You guys are always right, anyways. Come on. So, all right. Now we're answering these with the next ones. Let me.
Okay, let's see that one. Oops.
I shall fill these out real quick.
So number 2, check the data. My data. Mess me up.
Okay, so now it's asking us what is greater, N or DF? So DF is 21 and N is 22. So N would be greater.
And I like questions like that.
Yeah. What is the p-value? It's 0.001.
Do we need to play with the test at all, or does that not make a difference?
I already did. I put it back to not equal to.
Okay. And what was it again? 0.001? 0.001. Okay.
So in this case, since the A is 0.01 and this is 0.001, then we should
reject
instead of fail to reject. And now it's saying you decide to try another one. This time use that if it's greater than 0, and you keep the same level of significance, did the p-value increase or decrease? So let's look here. So if we say greater than, how about it didn't do anything? Well, hold on, I better expand out the, right?
Oh, so now we need to know what the other one was.
Well, that's what, so that's fine. Yep, so it increased, right? Because it's 0.012.
The other one was a 6, right?
No, it's lower, 0.006. So
it decreased.
That makes sense, because if it was a 6, then it wouldn't have been 0.1. It would have been 0.2 or 0.7.
Yeah, because the other one was a 2-tail, and this is just a 1-tail.
Yep, so it decreased. What decisions did you make?
So based on to the second option, right?
Yeah, we still rejected.
Yeah, you still reject.
Well, at least those are quicker. Based on your response from the previous question, what conclusion did you make?
Is it the third one?
We have sufficient evidence that there isn't. It was mean difference? Hold on.
There's difference. I mean, mean differences. There's 12 standard for the mean. I don't know how to read this very well, but
I don't either. Because we have sufficient evidence for something, right? Because both times we reject.
Mm-hmm.
So something, we have sufficient evidence for something. But I would guess it's the third one, right?
yeah.
Okay.
There is a mean difference, I think, yeah. Last one for this group. As we have seen, the p-value depends on the alternate hypothesis. In general, which alternative hypothesis will give you the smallest p-value? So greater than or less than, let's see. Looks like greater than for sure.
Yeah, big time.
Determine the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2. Input your answer below. What? We're still using the same.
Are we using the same information?
I thought the
Next 8 questions, and we're on question 9. Yeah, 8. So it's saying use it for 16,
Okay.
not 17 then.
So you change 95.95 on the
Well, but it
that
is
cell.
already. It already
Okay.
is 95.
Um,
Point estimate. That's confusing.
interval.
Information. Determine the 95% confidence group for the mean difference between the two groups using a group 1 minus group 2. Input your answer below. But this is confusing because are we using this before? Because it says for the next 8 questions, yet 17 doesn't.
Point estimate. Let me see. Figure out what is point estimate.
That's 11 questions it's asking us for, right?
I guess that's still having to do with that.
But it says use this data to answer the next 8 questions, but that's 11 questions, not 8.
Yeah. I don't know.
Or is
So
this
that's going to be
this isn't one of those generic questions that is just talking about.
sample standard.
It says using group 1 minus group 2.
Uh-huh.
Right.
Divided by.
That's what I'm asking. Is that like a generic question?
No,
Like
they have a formula on that one. This is
done without actual data?
Well,
No.
it could be. I mean, the 95% thing, isn't that always like a 1.96 for something?
Right.
But I remember what that was called, the 1.96.
Point estimate. Point estimate. Where? Point estimate.
So right here, we did do this correctly, right? If the p-value is less than the level of significance we reject, that's what we remembered.
Yeah, that's what we were doing.
Okay, perfect. I just want to double check since it was written there in black and white, just make sure we didn't mix those up. You know what I mean? Like, it just seems like a weird question when it's not. Like, are we supposed to use that or not?
Yeah. So the 1.96 is a z-score.
Right.
So let's see. Another way to express the confidence interval is the point estimate plus or minus a margin of error. Okay, so is the point estimate? Oh no. My goodness.
Let's just see. Point estimate. I thought I ran into that earlier. Is the oh, dang it, let me pull my other one.
What's the point estimate again? That's the,
I don't remember which lesson that was.
wasn't that just, didn't we answer that earlier in this quiz?
I don't know. Let's see.
No, it's a test statistic, maybe is that's what I was thinking of. I think I was thinking of the test statistic
Yeah.
point.
I feel like we just learned about the point estimate like last week, though.
Yeah.
Yeah, I'm going through the lesson. Hold on. Point estimator, chapter lesson 10. Let's see. It's the sample statistics point parameter.
That's that X bar plus or minus, like, remember Z times the deviation over the square root of n. Remember you got like the top and the bottom margin.
Oh.
That's so there's something in the point estimate, then you have the margin of error and the upper and lower bound. Like that's what we're answering next.
Yeah.
But it's all in that sort of deal.
Hold on, this is the interpretation.
Well, the margin of error is m equals 2 times standard deviation over the square root of the number.
Yeah.
But I don't know how you find the point estimate.
That's what, yeah, I'm looking at that.
Yeah, I'm looking through that. Yeah, so this is like point estimator. The statistic about are called point estimator. So because you have just one point of number line.
Okay, it says you've seen the sample mean X bar is an unbiased estimate of the population mean mu. Another way to say it is that X bar is the best point estimate of the true value of mu.
So isn't that just the average?
See, some error is associated with this estimate. However, the true population mean may be larger or smaller than sample mean. Instead of the point estimate, you might, yeah. So it sounds like we just need to find X bar.
Oh, okay. Point estimator.
So is it the difference? Is it the difference mean?
Oh, that's a good question. Which one is it?
Is it the 11.955?
It would be, wouldn't it? Because it was saying that in paired samples, we don't care the actual numbers of the different groups. We just care about the difference.
It says group 1 minus group, using group 1 minus group 2.
Yeah.
And it's asking for the X bar, where this point estimate, wouldn't that be 11.955?
Yeah, it should be.
Yeah,
I think.
I think we're overthinking it.
And then what is the margin of error?
And that is, does it have that in there?
3.199. Right, and then the lower bound should be, somebody get a calculator. I'll get a calculator real quick.
Right there, it should be the lower bound. It should be right there too.
Is it on there?
Yeah, go down a little bit.
Oh, is it right here? This right there?
The 5.30303.
Okay. Does everyone see that? 5.303 is the, oops, is the lower.
The lower bound.
And the upper bound is 18.607.
18.6.
That actually sounds right to me. Do you see that, Sam?
Yeah, I see that.
Okay, we ready to throw it all in and see what happens?
Sure.
Nope, we missed some. Well, we're wrong at the end there.
So the margin of error is wrong.
No, the margin of error. So the margin of error is wrong, but the 11,955 was correct.
But the margin of error is not
Hold on,
right.
I wonder. Hold on. No, that didn't change that. I was wondering if it was the not equal to. But how does
So number 17, we got it wrong.
So we missed 17, 18, and 19.
No, you got
No, 18 and 19 are right.
18 and 19 are correct.
Oh, I'm sorry. I'm sorry.
So there's something else that we need to be looking at.
Then how can that? Well, then all we should have to do is take this. Hold on.
The margin of error, well, let's just do the formula. Hold on, let's see.
Yeah, let's see. So
It should be 6.652 because 11.955 minus 5.303, the difference is 6.652.
So
makes sense.
18 point.
Which, if we would have just
7.
totally like thought ahead and realized that 11 minus 5 is not 3.
Yeah.
And 11 plus 3 is not 18. I guess we were just hustling through it. So I got so 6 point. So if someone wants to run that real quick, 6.652 and make sure that's right.
Well, let's see. What's the other problem that we're missing here?
No, that was the only one, wasn't it?
Oh, really? It's worth 2 points.
No, you're right. You're right. Hold on. And then, the greater than is not, or maybe, so I don't know if that's not enough information. Depends on the problem, maybe.
Oh, you know what? Yeah, because depending on the problem, it could be the less than instead of the greater than.
So if you want to check those two and one of you submit and see if those are right.
Okay. What number?
15 should be not enough info, and then 17 should be 6.652, and only one person do it. So that way,
Okay. What? Let me try. Let me submit it. What number?
I already did. It's right.
It is right. Okay.
For number 17, what number is that?
17 is 6.652. Nope, we just lost her.
Oh, she's gone.
I'll send it to her.
But it is not enough information and 6.652.
Okay. Well, I'm gonna real quick. You're gonna go through it with me one more time.
Okay.
And give me my answers again, so I don't have to think about them. So give me 1 second to start over here. And don't they give us the best score out of the two, right?
Yes, I don't think they average it.
Which is kind of nice, actually.
Yes.
Why isn't this hiding? You're supposed to hide. Thank you. Question 1. Yeah. 3.
Question 3 is 2.
I should remember that one. 4.
0.081.
You just want to keep reading them. That'd be awesome.
Okay. 5 is 0.407. 6 is 0.689. 7 failed to reject.
Okay.
8 is the second one. We have insufficient evidence that the mean of the difference is greater than 0.
Perfect.
9, hold on, let me get my thing to scroll. 9 is N.
Okay.
10 is 0.001. 11 is reject. 12 is decrease. 13 is reject. 14 is the third one. We have sufficient evidence that there is a mean difference. 15 is not enough information. 16 is 11.955. 17 is 6.652. 18 is
6.652, correct?
Yes.
Okay.
18, 5.303. And the last one is 18.607.
Thank you very much.
No problem.
We'll just make sure I didn't screw something up. 0, no, 100%. All right. So that 6 point whatever, I'm just looking in this spreadsheet. Yeah, sure enough, they do not have that in there.
And I don't know what the standard error of the mean is.
Right. So what I'm just wondering is like, if I get, it's like I want to add that. You know,
Yeah.
what's that? What's the, sorry, I'm being an idiot, margin of error, right? I'm going to add that
Yes.
into my spreadsheet real quick. Margin of error equals the mean minus that one. There we go. So now I have it for the next time. At least I'll kind of should remember that. I'm going to save this right on my desktop for now. All right, I'm going to stop the broadcast.